Sure you don't want to center yourself in the broadcast?
No, not my nostrils, at least. It looks good.
Yeah.
And I'll announce this on the meetup page as well.
So the OSX support is missing. Let's see. He says he needs to do file launcher for file system events and generalized implicit dependency detection. Using trace.
I think it's just better. Oh, sorry. You grab it.
Yes, it's not running, trying to build it.
Only one taker so far. Before anybody joins, I work at Weka.io now.
Oh, you do?
Yeah.
You do?
Yes.
Congratulations.
Thank you. I'm going to Israel on Saturday morning to meet with the rest of the team because N-1 are over there. So I need to get up to speed. I'm very, very happy. You know, there's only a couple of companies who use D at that level, and I'm joining one of it. I'm very excited. That's the summary. We'll talk about it later.
Congratulations.
Thanks.
That's really cool.
Yeah.
First future D millionaire right here.
After those guys. Oh, okay. Shall we start?
Yeah. So let me see. I want to do screen share. Have we gone through what editors people here use?
Emacs.
Emacs and Vim and Sublime Text. Okay.
Do you use DCD?
No.
I did.
You do, okay. It's
It's the decompletion daemon.
yeah.
So Brian Schott,
Mm-hmm.
is that how you pronounce his last name?
I used this target generator. D scanner, I think.
Okay. Yeah, so
I
he has
can make my
dfix, dscanner, and DCD.
Uh-huh.
Yeah. So it's basically the autocomplete framework, which depending on your view is either great or annoying in Emacs. And
Annoying everywhere to me. Type a window
so then you won't like
pops
it. So,
If it's quiet and then I press a key to see the window, then I might experiment with it. But as typing stuff popping up, I don't like it.
but there are some things about it that I do like though, because one of the things that's actually pretty nice is that it'll actually it's part of, I guess it's part of fly check mode. I forget I installed the whole thing, but it'll actually check all your syntax. So if you make a syntax error, It'll tell you right away while you're typing. You don't have to wait until you exit and save and do a compilation.
Maybe it's
I don't
configured.
use Emacs.
Yeah, so that part's actually pretty convenient. And to be honest, I set it all up at once, so I don't remember which parts were which and what I did to make it all fit together. But it actually works pretty nicely though.
Vim has something like that called Syntastic. I'm not sure if you've played around with plugins very much.
Use a SPF 13 like set of things, but that can mix results. What's it called?
Syntastic.
Yeah, whoever did the
And it pulls a whole bunch of languages. It gets C, C++, Perl, Python, almost any language. Sorry.
yeah, this one's done pretty well in that you really, I tend to find D's, despite the complaints about it, D's compiler messages to be generally pretty good. And it's telling you, it gives you normally, well, not the whole compiler message, but the first line of it. So you actually get pretty decent help inside the editor when you make mistakes. It's really not bad.
Just avoid mistakes.
What's that?
I'm just kidding. Just avoid mistakes.
Okay, so you can say newbie mistakes if you wish. Please go ahead. I'm not able to type 10,000 lines of code without a syntax error. I can't do that.
My problem is worse, yeah, because I'll be working on a little box, so I'm compiling on a really slow system. So I should be using something like that, so I can catch those things instead of waiting for a while and then just get there. I should do that.
There's even a mode, an Emacs mode somebody wrote, which I haven't been using too much, but will actually run the unit tests in the editor. Which is awesome. So people have been trying to make tools.
Yeah, I find that the tooling level is acceptable. It's not, there's enough things that recognize D now, which is surprising.
I'm not that impressed with the debuggers though.
The debuggers?
They need work.
Yeah.
So part of the problem with that, as Andrew mentioned a few weeks ago, is the name mangling.
Mhm.
There are certain things where it's non-deterministic, and the name demangler that we have built in doesn't get everything. I am pretty happy with DCD though. It's a whole lot lighter than a lot of the Java completion daemons because they'll spawn up multiple instances, but the D-completion daemon will share.
No, this is a work machine. It's a pretty fast box, but I find that DCD runs fast enough too. It doesn't.
It does.
Yeah, it runs fast. So.
All right, I'll kick into this and we can run through and you can slow me down. I threw out this topic as an area of personal interest and also work interest. And I thought I'd share some notes on it in case anyone is brave. So just the general topic is GDC on ARM platforms, which is a theme of mine. And specifically OpenWRT. So I went through this exercise last month or maybe earlier this month. And were some challenges to kind of get there. So I'll jump in. So I presented before on this topic of embedded systems and why I've chosen D as the language to use. And I think, as a just general premise, I think just working in the language is very productive. Now, does that translate into other problems when you try to share your code with somebody else or you try to explain your rationale for why you're not using, fill in the blank? And that can be counterproductive. But I think as a general stance I have right now, having very close access to people who are directly involved in doing stuff, even though I'm almost not present in the community itself. It's nice to be able to, if I needed to, contact somebody and maybe get some answers. And I'd say we can't say the same thing for a lot of other languages. You might get a lot of, flames on a C++ group if you chime in on some silly question. But you may get flamed on the D forum, but at the very least, if we've got a real problem, I think there's somebody we can go talk to who might be able to give us a quick answer on why is it this way. And so I like that. It's not perfect, but so I think one of the first questions that you have to ask when you're looking at embedded systems are tool chains. And typically, there are tool chains under different licenses from different sources and so on. And there's many embedded architectures out there, microprocessors, microcontrollers, all flavors of Unixes and BSDs out there. And people forget that because we all kind of live in this sort of monoculture of stuff, but we're probably in any given cool tech company, there's a lot of people using Mac OS X, and people forget it's a Unix, but it's actually it's based on a BSD flavor, and they also think about the most popular device out there right now is probably based on a BSD, not a Linux, and so that's it's a factor when you're thinking about choosing platforms, and some people, particularly there's a school of people who work on embedded system stuff that are only going to be working on a Windows platform, and almost always then you've got some kind of IDE that you're working with, like a specialized compiler that comes from your semiconductor company or whomever you're working with. And this is an open question. I know there's a Visual Studio plugin. Have you guys used it at all? The Visual Studio stuff?
No, Visual D.
Yeah. I've tried it out. I think people who love Visual Studio love the debugger and the facilities that come with it. And from what I hear, it's second to none. Is there any D support with Eclipse? Has anyone looked at that?
I believe that there is, but I don't know how much it's used.
Yeah, because Eclipse is one of those things. I think it gets used as sort of the ugly stepchild of IDEs, and people grab it and just say, hey, go to work over here on this, and they throw a plugin on top of it. But it generally speaking, I don't think there's too many people who really love Eclipse. Like, who's going to go to bat and say, I love Eclipse for these things? It's usually like the Java people love IDEA, IntelliJ, as an IDE and swear by it. But so, I think for the time being, for embedded systems, we're kind of relegated to, command line build stuff. In terms of commercial options out there, I haven't actually gone and looked to see if there's any commercial companies actually have some kind of supported D for embedded systems type thing. But certainly in the realm of, C, C++ compilers, there's all kinds out there. So then I guess the question, if you were going to pick this up for a project that you were doing for some, internal thing, you just have to check out the license, make sure your work or whatever doesn't have some clause that says, there's some problem with the DMD compiler. I know we mentioned that before, that there's some bit of semantic license stuffed into it, but I don't know if that affects the actual binary that gets does libphobos have any encumbrances that anyone knows of as far as licensing?
No.
It's all boost license.
Phobos is all open now. Only DMD's backend has a piece of code which is not open source.
Okay.
As far as I know.
So it shouldn't affect users of LDC or GDC then, I think, unless they borrow some of that code and put it into those. So, I guess the question is, so then why aren't more people out there using D for this kind of stuff? It's such a great systems language, and I think it's not technically it's not early days for D. I think it's just hasn't been on the radar. I started using Node.js on ARM devices back in 2010. Nobody was doing that at all. It was not on the radar at all. And then suddenly now a lot of people do it, but I don't think it was necessarily, the case back then that it was a bad idea or anything like that. There wasn't great tooling support. Every time I had to build Node.js, I had to customize the build environment to actually work right. And so I think the experiment here was to see could it be useful and could it be done? Could you build a commercial product with it with D? And what are the advantages? Well, one of my big advantages that I've stated openly before is that if you're using JavaScript or Ruby in some commercial product that you're going to manufacture and send off to China or Taiwan, you're going to lose your source code. I mean, because it's source-based delivery, it's interpreted. So doing something other than that makes sense. And so that was one of my motivations to try to move away from that, even though I feel like it's really productive and that was my decision. So so everyone has their pet platforms when you're working on stuff. Like a guy, somebody who works on set-top boxes will be asking about MIPS, or somebody's got some exotic ARM processor, like an ARM 64 bit processor, or some RTOS. And since I'm completely out of the loop on the compiler projects and the efforts there, I think somebody else can comment on why there's not better support. If you look at the support list for LDC or GDC and look at the platforms, and my take is that they're lacking motivation and access to resources to go pursue other things beyond the immediate either personal interest or maybe some commercial interest driving who's working on compiler stuff. Do you guys have any comments on the compiler people or the compiler world? You ran into some of them at the D conference. Did you get any sense of what they need or what they're doing?
I appreciate whatever they do. I have nothing to contribute in that area myself, so I just love what they do. And Kai Nake had a talk in DConf talking about limitations, floating point support for certain platforms. That's all I know.
Okay.
I'm assuming those platforms don't already have floating point, or maybe they do, but the compiler doesn't produce code for it. Or maybe they need emulation functions for those.
Okay.
I'm just assuming.
So if you might have an ARM chip like an ARM v5 that has no floating point yet.
Uh-huh.
So you would just have to compile if you're using GDC. I don't know what happens with DMD. There's no DMD support. Maybe LDC.
No. Yeah, LDC or GDC
might have a problem producing the right code. Yeah. Okay. So my kind of request, I guess, would be that since you're in the D Foundation, that they consider offering some bounties to support the kind of work on the more exotic aspects of the language, like the mobile stuff or the ARM v7 or MIPS or whatever.
Yeah.
I don't know if they've done any of that kind of
that
bounty source.
Stuff is interesting. I mean, there were some bounties for D-related bugs. Some people made some money off of it. Some people didn't.
It's really just funding directly the people who are going to work on this, not as a kind of a treasure quest.
Yeah. It is in the plans. There has been, and I shouldn't lie, we don't meet weekly or monthly. As we found it.
I'm telling you this to
yeah.
kind of bubble this information up.
I think we're waiting for the non-profit status still for the thing.
Thanks for
But there are
You don't actually have the nonprofit status?
not yet. It takes months, sometimes years. We heard. You apply for it and you wait for it. They review whether you're nonprofit or not.
Took me 3 years to get my 501c3 set up, and I was legitimately trying to have a nonprofit, not like a scam to funnel money.
Oh, okay, but the foundation itself is some form of legal entity at the moment, right?
Yes.
Okay.
You can donate money to it. Some people do. It has money through DConf attendees and other sources. And there are plans to use that money for exactly what David described. Take this money, do this. But it also requires some planning organization, like you be the judge for that work. You check for the deliverables. There must be people doing that.
So,
Yeah.
my little request. Okay, so in terms of like compiling D then for these devices, with your typical compiler that you've got on your laptops, you're probably not going to be able to target these devices. But in general, if you were going to start out with something, you would pick a device. So if you've got a Raspberry or your Android phone or some target, and you need to know a little bit about it. So my focus was on a Linux platform, ARMv7. So there's nothing that seemed too exotic. One factor that I didn't consider when it started out was the C library choice. And so typically everything's glibc, but it happens to be, I learned later, OpenWRT defaults to something else. And Android uses something else too, like Ionic, which is like some shrunk down libc also. So this can mess you up big time and certainly cause problems later, and I'll get to that. Distro, so if you're targeting a particular distribution, we will typically, if we're using Linux for stuff, we pick out a distro. We're like, oh yeah, I'm gonna align myself with Ubuntu or Fedora or something. But in the embedded device world, it may be less about the platform, that you're choosing so you can install things, but it could be actually a whole build system. It's big because you're always building your OS. You're not just installing stuff, but you're going to build an OS. So you may need to pick a distribution approach that suits your preferences. And this can make a big deal about how you get to spend your time, because you choose like a completely source-based distribution like OpenEmbedded. You can spend days, if you have a really slow system, building stuff. But if you pick something that's already kind of not completely from scratch, then you can get going pretty quickly. So in terms of the approach for toolchains, I characterize just compiling on target is very easy. If you grab a Raspberry and you can get the D compiler somehow, one of them, get it installed, that's like almost a no-brainer. Medium easy would be grab a pre-built cross-compiler. So I'll show how to do that. Generally speaking, if you can navigate through the various versions of compilers and make sure you grab the right one for your host, it's easy. I'd say hard is use a firmware distro building system. So this would be the approach you take with the Android open source project or OpenWRT or OpenEmbedded to actually build everything together, include your D code somehow, get it built and put into this platform.
You want to go to the presentation mode? Are you reading from slides?
Oh.
On the left side.
Yeah, what the hell happened?
Or are you seeing different?
Yeah. Sorry about that. No. So, what's the thing? That's strange. Okay. Is that online? No.
Shift F5, just start the current slide.
No. All right. I'll just navigate through this.
Okay.
Sorry about that.
No problem.
I thought it was a long intro.
Yeah. Someone stop me next time. Okay, so, geez. And I'll post these slides later in case anyone's interested. So in terms of, let me just catch up to where it's supposed to be. Okay, so then the other approach is of course you can build your own cross compiler, and that can actually turn out to be harder than imagined or really easy, but generally speaking always a pain. It's hard to get it right the first time. So my first experiment was originally just D-Lang on an ARM target. So I was evaluating different languages on an ARM platform. So I'd recommend, if someone wants to just dabble around and just feel like I want to expand my D stuff onto devices, I would grab Arch Linux ARM. I like Arch because unlike Debian and Ubuntu, it's a community support, so it's rolling. So at any point, you, in theory, can do an update, and it shouldn't break your system. And you should always have the latest stuff. And this is something that drove. This is what drove me to Arch Linux ARM originally, was a number of the vendors who were putting out little Linux devices were stuck on like an ancient Debian, like just dinosaur era. So every time I go to install something, all of the package sources were deprecated, or the keys had expired, and you try to install this thing, it depends on something you can never install. And this is the madness of using a kind of fixed version released system like a Ubuntu or a Debian, is that you're going to theoretically build a device and put it into production for years and years, and then one day your user or someone's going to go in and try to run an update, and they can't because they've moved all the package repositories. Now, Arch Linux is not perfect. If you run an update, that could damage your device, but I know the guy who runs the project, and they build Arch on devices. They use distributed GCC, and he's got this really awesome build farm of stuff. So it's aside from being a cool approach to how they do their project, he just does this as a hobby, and I got him kind of turned on to commercial work and sending him some commercial projects to work on, and they've since been able to expand out to, there are companies who really got sick of using things like OpenWRT and OpenEmbedded and switched to Arch Linux as an approach. So that's my little pitch for that. Go give it a try. It should be an easy experiment, maybe max 2 to 4 hours. So the second experiment is to use a pre-built cross compiler. I had focused on GDC because I could get GDC pre-built already on an Arch Linux ARM on an ARM v5 processor, which nobody really supports. So I was cool using it. I think people have other, generally speaking, it seems most people are on LDC or DMD, but I found it valuable to be able to leverage the GCC toolchain because it is going to be everywhere. So in terms of grabbing it, if you go to the GDC website, here's a link. You can get it for your Linux box and cross-compile for a ARM target, and that will save you some time versus trying to, if you've got a big project or you need to compile something big like VibeD, trying to do it on a little dinky box that doesn't have enough memory even. This is a better approach. So this not that hard to do. I recommend definitely try it. Move to the next one. So building D on top of some distro system. So we actually went down the road a little bit of building D on an OpenEmbedded Pokey-based distribution for an Atmel microcontroller that runs Linux. And it did work. I didn't spend much time to vet the platform to make sure, even if you can compile Hello World, that doesn't tell you that the whole system's going to be supported, as I found out. So I do want to circle back and look at that project, but I put it on the shelf. So in terms of OpenWRT, so that's, for people who are not familiar with that, that seems to be the one of the platforms of choice for many of the router companies. So if you've got a router, there's a possibility, it's not guarantee, but there's a good chance that it's running some flavor of an OpenWRT system. And that gives you essentially like a build route and tool chain and a sort of mechanism for configuration and a mechanism for building packages. So if you, venture down that road, you kind of need to identify some hardware that you're going to use. The actual process for getting started, I claim, is both fun. I don't know if it's fun, but it's certainly time-consuming. And you can grab the stuff and pull it down and build it. You'll end up with a tool chain, and then you can generate firmware binary for your target. Typically, what companies will do is they'll take the original distro and then they'll build their own like SDK out of that stuff. And then if you happen to have that, you can build stuff for their device using that tool chain. So in terms of OpenWRT, then if we already have GCC toolchain, then that should get us pretty close to a GDC system. And so you might think it'd be super easy and go on there and just run the cross-compile instructions. And I thought this would be pretty quick, and it turned out to be. I never did get to the bottom of why I was having so many problems, but once you apply your patches for GDC, then I jumped over to the configuration of GCC, and I ran into all kinds of problems because part of it's understanding the fact that the OpenWRT build route is a little bit different than maybe other projects, and so that doesn't totally jive with the normal approach for configuration. And so this actually, I wasted tons of time on it. And so I kind of got to the point where I thought, okay, maybe, thinking about it, the OpenWRT system gives you cross-compiler toolchain that you build when you build the SDK, essentially. So the original thinking was, well, maybe I can stick GDC in there somehow. So I think there's a way to do that. There would be a way to patch it so that the original SDK that it gives you includes GDC. That would take some brain surgery on the build system I just didn't have time to do. So it got into this problem of like, well, how should I do this then? And looking at the problem for too long, I decided that I would just give up. And then at some point I realized, there's another way. I know my target. I know the general details of the kernel, the router device that I'm going to put this on. I could just use a different cross-compiler toolchain. Forget about trying to build out of their build route with OpenWRT. Build this other thing, and then I ought to be able to generate binaries that will work. So I did that. Cross tool in G is excellent, and a little time consuming to get into maybe the first time. Essentially what it does for you is it leverages the beauty of the menu config system of the Linux kernel, and so gives you a way to kind of visually go in and configure a entire tool chain for I think generally speaking it's for Linux targets, but maybe it works for other stuff. But you can kind of select all of the attributes of your tool chain that you want, including different language support, which kernel headers, things like that. And then you just hit build and it will go off and do what you've instructed it to do. So I'd say this is the easiest way to get a cross-compiler built without this sort of fewer tiers approach. Somebody already did this actually, and I kind of noticed it too late, was that up on the GDC website there was some good instructions. It's not totally complete, but this is a starting point. You have to build your basic GDC, your GCC, and then go back and basically reapply the GDC stuff on top of it, and then rebuild the tool chain, and then voila, you're set. So to kind of get through this part, sort of the boring details of your tool chain is, which GCC version you're going to be working with. This C library target that you're going to go after. In my case, UClibc, OS, kernel version, the CPU architecture. This can get a little complex depending upon which, you have to make sure that the string matches a real target. And floating point unit, again, this can be tricky to know what you've got. You may have to read a reference manual on your device to know. And there may be a few other peculiarities, but generally speaking, if it's not a completely exotic platform, the internet will have somebody who's already kind of done it at least once. So then just do CTNG build, and when you're done, you've got GDC, and you can start building stuff. Now, the sort of last thing that I hit my head on was getting stuff onto my router. So when you have a base OpenWRT device that actually doesn't have DHCP set up, that doesn't have SSH set up, so you have to go and configure it through debug port, and then copy your stuff onto the system. So in terms of problems I ran into, this was a big one, was that UClibc doesn't have complete libm support. And so when I got into just some code that I needed to compile, I found as I was compiling, I was getting these undefined symbols, and found that it was consistently the long double use, and to work around that, Elise suggested to just, for all those math functions, just define them in the source somewhere at least once. And if you weren't actually really using those things, but they're used in Phobos somewhere, but as long as we're not needing to use them and we don't have to provide an alternate implementation, then we just return, it doesn't do anything.
Or another workaround might be, in the future, you never use long double yourself, which is probably a video. Just stay with double float, and you won't hit those asserts there.
Right. Another thing you run into is once you get your binary onto the target, it may be looking for some libraries that the tool chain had hard-coded into the shared library that it gets compiled with. And so you may need to soft link some .so.1 for some libraries that you depend on that'll be on the platform. The other problem I ran into is the binaries were a little large for OpenWRT type devices. They're pretty small in terms of the available RAM, so I have to figure out how to work around that. That was kind of a bummer, because most of the platforms that I have been using up to that point have not plentiful RAM or plentiful storage, but reasonable amount. So that's pretty much my little thing on this topic. I'll post this out onto the meetup group. If you guys have any questions, just shoot them to me.
Awesome. Just in time, Jason just joined. Cool. Say hi to him. Hey, Jason.
Hello.
Hey guys, okay, you're muted, of course, we can't hear you, but also because I don't have my speaker up here.
Turn off the share. If you guys have any questions, just shoot them to me.
Awesome. Just in time, Jason just joined. Cool. Say hi to him. What is this? Hey, Jason.
Hello. I think we're behind.
Hey guys, okay, you're muted, of course, we can't hear you, but also because I don't have my speaker
really
up.
behind.
How come we're behind?
Type in there, tell them we're time delayed.
You guys have any questions? Shoot.
Just avoid
Just in time, Jason just joined.
Cool.
Say hi. Hey Jason.
Hello. I think it was about.
Hey guys, okay, you're muted, of course, we can't hear you, but also because I don't have my speaker up.
Has GDC on there already in their repo, so I was able to pull that down on there. But it was an old version. What was your experience with trying to move up to more recent versions of D? Because even going into Dub, do you go back much past 2068? You start getting compile failures.
A lot of the new cool stuff, like the allocators and things like that. You need something newer, but I haven't jumped ahead to the latest and greatest. Is that I tend to find that it doesn't help. Like if you're, as much as possible, keeping yourself from having too many external dependencies that helps you, saves you sometimes. But yeah, sometimes you can't avoid it.
So, how about the sound on your system? Are you lagged too?
Let me turn up my sound. I'm gonna try to.
Can you hear me? Oh no.
Echo.
Okay, I have to turn this microphone off. Hold on. Where's my microphone mute?
I'll mute my things up there.
Okay.
Or I can mute from the tool itself.
Jason, are you able to
It's up at the top.
do a mic check here? Oh no.
Jason, can you hear us now?
Can you hear us in real time? Can you do a mic check? Or no mic? Can you try your mic, Jason? Oops. You can dial in. No.
Is there a dial in here?
No. Cell phone.
It's true.
So we're doing this a very Zen hangout where it's just silence.
Are you saying we weren't broadcasting? People couldn't hear what you were saying?
No.
It's time delayed by like 30 seconds. And Jason doesn't have a microphone. So
No microphone.
I can hear. Can you dial into a number here?
Oh, he doesn't have a microphone.
Yeah,
So
can you dial in? Maybe he can dial in.
dial into what?
Just a cell phone.
Oh, Jason is the presenter.
Yeah, without a microphone.
Oh, without being able to talk.
Okay, how do we do it? Dial in?
The phone.
Call phone.
Call
Put
phone.
the phone on top of the laptop.
Remember this?
Okay,
We're supposed to be technically sophisticated
Jason.
in this group.
okay, let me unmute my microphone now. Oh yeah, software mute. Hi Jason, can you hear me? No, you need to mute, I guess. Okay. I'll email you. Okay, no need to tell. I'll email you a phone number. Please dial that one.
Oh yeah, software.
Am I sharing my
Hi
desk?
Jason, can you hear me?
Can you email your phone
no, you're
number
not.
to him?
How's this gonna work if we're 30 seconds delayed?
I'll email you a phone number.
Oh,